Hello, my name is Sophia, and this is my course project for Introduction to Oceanography. For this project, I will be discussing the primary productivity in near polar zones. Phytoplankton is the primary producer throughout the ocean. It is considered the base of the marine food chain. It is constantly converting energy into organic matter. Primary production has always been very important in the ocean, since it provides energy to each marine organism in the food chain. With the process of photosynthesis, organic matter is being created by deleting carbon dioxide from the picture. Due to this, the oceans have always been essential to the Earth's carbon budget throughout. In the near polar zones, primary productivity is highly based off of the seasons, due to the amount of light available. Along with this comes the amount of nutrients present at the time. When it is warmer, the ice caps melt, making it a primary motivation for productivity to take place, due to the increase of stratification and light. Stratification is the differences in density of water. So you could think of warmer, lighter, less salty water on top of heavier, colder, more salty water. When mixing occurs, it allows the heat to slowly seep deeper into the ocean depths. When you are looking at the data presented, it shows phytoplankton levels. Since the temperatures stay so low, consumption rates are low, but nutrients are present all year round. This is nearly opposite of the temperate zones. The data collected further validates these claims. Moorings are placed in these polar zones for constant analysis. Phytoplankton relies on chlorophyll A, a photosynthetic pigment. Measuring this amount can help determine the amount of phytoplankton present. By constantly measuring these levels, scientists have an easier time understanding seasonal and climate changes in water temperatures and the availability of nutrients present for production to occur. Understanding and knowing the changes in phytoplankton is vital to knowing the health of the marine ecosystem. Think of everything being connected in some type of way. Everything that happens has an effect on something else. The Ocean Observatory Initiative has placed ocean arrays to track chemical, physical, and biological changes taking place in the waters. In this poster, we are focusing on the near polar zone arrays. Armingersee Array, Southern Ocean Array, and Station Papa Array. Each array tracks the amount of chlorophyll A being produced in the region. In the areas of where temperatures are colder, nutrients become scarce, which equals phytoplankton growth to dwindle. When you are looking at the data, it shows that chlorophyll A concentration is higher at the North Pole than it is in the South Pole. This is because the sun is located closer to the North Pole. It is easier to see a connection between geography and the rate of production when you are reviewing the data presented. When you are reviewing the data from each of the arrays in the near polar zone, you're able to see the changes in the concentration of chlorophyll A based on seasons and location. Coastal waters seem to have more production due to the runoff and the shallow bottoms along the continental shelf, blocking the nutrients from sinking deeper into the depths. Other limiting factors in the coastal waters could be temperature and thermocline. Thermocline is where the temperature of the ocean sharply decreases. This would be an indication of two layers of water coming together where it's different temperature and density. Primary production is highest near the poles and lowest near the equator. This is due to latitude. Surface chlorophyll A levels are different at each array, with the Arminge array seeming to have the most variation. It reaches levels of up to 25 chlorophyll A concentration during the months of May through June. Southern Ocean Array seems to have the least variation, staying at about 1 to 2 throughout the entirety of the year. Papa Array also shows variation between 6 to 10. All in all, the graph shows relatively constant levels of chlorophyll A throughout the year, with the exception of the months of March through June. This could solely be based on seasonal changes. At polar zones, temperatures are low and salinity is high, allowing for constant mixing of ocean water. Anything can alter seawater properties: location, human interaction, physical features, and many more, ultimately altering primary productivity. If you look at the graph on the poster, it shows the data of the concentration of chlorophyll A of the 3 stations in the near polar zones. Knowing there will always be questions about this, I'd say my main question would be, what are the similarities and differences of chlorophyll A patterns between the 3 locations? It is very important to understand the effects we put on our oceans. We are causing many issues. All of the greenhouse gases we are putting out into the atmosphere alter the ocean in some type of way. We could play a huge part in changing production, causing it to go down, as well as the issues that we are producing when it comes to climate change. But when you think about it, we're causing all of these issues that are causing problems for the ocean, but couldn't we also cause positive changes for the ocean as well?